Okay, thank you. So my name is Başak and I'm a second year PhD student at University of Calgary, and my specialization is in learning sciences. And my dissertation will be around teacher development and a new perspective with public computing.
Hi, I'm Stephanie Helvaci. I'm a third year PhD candidate at the University of Calgary as well. My work is similarly in public computing, but looking more at facilitator, scaffolding, and infrastructuring.
I'm Steve Uzzo from the New York College of Science. I'm their chief scientist. Most of the work is in learning science, but I have a foot in network science and data science as well, which I try to bring together. I guess our section was on the PAC. It's an algorithmic thinking game that is intended to be used anywhere, not just in the museum. Fundamentally, where this idea came from was to find a way to acquaint museum visitors with the complexity of sustainability science, which was intended to give people an introduction to systems thinking and actually think about how do we bring these into an environment which is playful, which invites mainly the people that we don't think would come to be interested in even using Scratch or other kinds of computer programming environments, but give them a sense of what the power of algorithms are by actually manipulating an avatar in an open world game that has to solve problems by developing algorithms that can actually help them get to the particular objectives and goals that they have. This was intended to invite them into that and give them some empathic ways into thinking about how to solve problems in an environment. Yeah, so I guess what would be interesting to me, what your thinking is in terms of how you would approach that and how you think about that in relationship to the work you're doing.
Yeah, so our public computing work is itself an invitation to diverse museum visitors because we're trying to take professional scientific simulations and put them into a public museum space where visitors interact with the open source code. And our invitation is an interesting one because we are deliberately using a text-based programming language, but our intention is to really open up the complexity of what some of our visitors have called real programming. The other important thing about what we're doing is this idea of computing as something that goes beyond just the code that we have and includes especially the social interactions with family members, with other visitors, and with facilitators in the space.
Maybe I can mention some of the design aspects that invite visitors. So the choices, the visual choices are like deliberately chosen as like gender neutral, I can say, and the visitors can add some animal images, which is fun because they start seeing those images they added to the screen, and like this instant results kind of encourages them to go further, to modify the shapes or change the parameters, and it kind of turns into an inclusive activity. The aesthetics of the design is also an important factor in terms of invitation.
Our approach to thinking about programming. So it's actually sort of the flip side of what you're talking about, which is interesting because thinking about how you change something, that helps lead you into thinking about, well, what effect does changing one thing have on something else? So what we do is the pack is actually a pack of creatures, and the creatures are functions, and you have to actually gather these creatures, and the creatures actually help you solve problems, but they can only help you if they work together. But it's intended to give you a sense of how collaboration and cooperation work in the setting of this open world, which is a sort of a different kind of invitation into programming than the more procedural. So you're trying to get collaborative groups to work with the text-based programming. So I'm thinking about how does their collaboration reflected in those interventions that they do with the text programming?
This is one thing I noticed very often when, as you said, a kid starts creating something, the exhibit allows the other visitor to change something on top of it. So it is kind of a collaborative kind of environment, even if the visitors don't know each other. And when they see something cool on the screen, or they engage with it and they try to make it better in their way. So it is kind of a playful environment for that. And we mentioned a pre-verbal child. Her dad and her mom started interacting with the exhibit and did all the changes to impress the baby, to like start some kind of jiggling, and that turned into a family fun event. And this this specific case really highlights the possibilities of this exhibit, very different possibilities that we haven't imagined before. Yeah, so it's very exciting in that realm.
Yeah, so I guess thinking about how that idea relates to what we do with the pack is because the focus is really on algorithmic thinking and understanding the power and value of algorithms rather than thinking about how do I write code to do something. The idea of them coming away with, well, you know, you can play with algorithms and you can play with values and functions, which is part of the computational thinking. So I guess it's sort of similar goals, but we're sort of coming at this almost from the opposite ends, which I think is really interesting.
Yeah, our exhibit is called Hack the Flock, and it is a permanent exhibit at the TelSpark Science Center here in Calgary. So you can find more information about it at our supervisor, Pratim Sengupta's website, which is m3lab.org. On that website, there's a page for Hack the Flock, and there's also instructions on how to download all of the code and everything you would need to run it at home.
So the pack it's an open world game. It's available for free on tablets at the Apple Store, and it's available for Windows and PC at the NISI, the pack webpage, and it's just a download and go.
Thank you.